Okay, today we are going to start exercise 4.1 from the lesson quadratic equations. But before starting, we must know some important points regarding quadratic equations, right? So firstly, what do you mean by quadratic equation? Quadratic equation is an algebraic expression having degree of 2, or simply it is a polynomial equation with degree 2. And here degree means, as we know, highest power of expression or polynomial, right? For example, x square plus 5x plus 6 equal to 0. And here we can say highest power of this equations is 2. So the degree of this equation is 2. So it is an example of quadratic equations, right? Beside this, one important thing, त्यो के हो भने, after solving the quadratic equation, we can obtain two values of variable, right? And that so obtained values of variable is also known as roots of the equation or zeros of the equation or solution of the equation, right? And we can solve quadratic equation by factorization method or by using quadratic formula. So firstly, let's say by solving this equation by factorization method, right? So for that, let's proceed to another page. Okay, here we have taken an example of quadratic equations. Okay, let's check. X square plus 5x plus 6 equal to 0. X square plus 5x plus 6 equal to 0. Okay students, now according to factorization method, we can solve this equation by splitting the middle term, right? And here in this equation, 5x is middle term, right? And here we need to break this 5x into two numbers so that when we multiply those two numbers we get this 6, and when we add those two numbers we get this 5, right? So it's simple equation, so it can be solved like this. X square plus, and this 5x can be splitted into 3x plus 2x, because when we multiply 3 and 2 then we get 6, and when we add 3 and 2 then we obtain 5, right? So plus 6 equal to 0, and from this pair we can take x as a common, so here remains x plus 3 plus, and from this pair we can take 2 as a common, so here remains x plus 2 in 2 3 are 6 equal to 0. And here we can see x plus 3 and this x plus 3 is common, and here remains x plus 2. Now x plus 3 make it equal to 0, then we obtain the value of x, that is minus 3. And similarly x plus 2, okay, make it equal to 0, then we get another value of x, that is minus 2. Okay students, in this way we can obtain two values of variable after solving the quadratic equation, right? Now we can solve this equation by using quadratic formula, but before that let's know about standard form of quadratic equation, right? And as we know, standard form of quadratic equation will be ax square plus bx plus c equal to 0, where a represents coefficients of x square and b represents coefficient of x and c is constant part, right? Beside this, one more thing, a should not be equal to 0. This is standard form of quadratic equation, right? Okay, now let's solve this equation by using quadratic formula. For that, let's proceed to another page. Okay, we have a quadratic formula, and that formula is x equal to minus b plus minus root over b square minus 4ac by 2a. And our question is, okay, let's check, x square plus 5x plus 6 equal to 0. X square plus 5x plus 6 equal to 0. Okay, now we are going to solve this equation by using this quadratic formula, right? And as we know, this equation is already in standard form, and according to standard form of quadratic equation, here a equal to, okay, we should assume here 1 plus 1, b equal to plus 5, and c equal to plus 6. Now let's solve this equation by using this formula, and here x equal to, okay, b equal to, we have 5 minus 5 plus minus root over, and b equal to, we have 5 and this square minus 4, a equal to, we have 1 into 1 into c equal to, we have 6 by 2 into a equal to, we have 1. X equal to minus 5 plus minus root over, and here square of 5 will be 25 minus, and here 4 1s are 4 and 4 6s are 24 by 2 into 1 2. Again, x equal to minus 5 plus minus root over, okay, 25 minus 24, 1 by 2. And here, as we know, if there is root over any number, then that number possesses both sign, plus and minus, right? It means this 1 possesses both sign plus and minus. And here, to find the value of x, firstly let's assume the sign of 1 is minus. Then what will be the value of x? Let's find over here. X equal to minus 5, and here we have assumed the sign of 1 is minus, and this root over 1 will be equal to 1 by 2. Then x equal to minus 5 and minus 1. After adding, we will obtain minus 6, and that minus 6 should be divided by 2, and finally we obtain the value of x will be minus 3. Now again, let's assume the sign of 1 is plus. Then what will be the value of x? Let's find over here. X equal to minus 5, and here we have assumed the sign of 1 is plus, and root over 1 will be equal to 1 by 2. Then x equal to minus 5 plus 1. After subtracting, we will obtain minus 4, and that minus 4 should be divided by 2. Then finally we will obtain minus 2. In this way we have obtained two values of x. First one is minus 3 and second one is minus 2, by using this quadratic formula, right? And we came to know these two values of x are same as the values which we had obtained over here through factorization method, right? Now lastly, let's talk about discriminant and nature of roots. Firstly, what is discriminant? Discriminant is that which determines the nature of roots, right? It means after solving any quadratic equation, what kinds of solution or what values of variable will be obtained can be determined by this discriminant, right? Or simply, it helps to identify whether a quadratic equation has two distinct real roots, two equal real roots, or no real roots without actually solving it, right? For discriminant, we have a formula, and that formula is D equal to, D stands for discriminant, right? B square minus 4AC. And by using this formula, we can get the discriminant of a quadratic equation, and according to that discriminant, we can easily know the nature of roots without solving that equation, right? For example, if discriminant is greater than 0, then we obtain two distinct real roots. Distinct real roots means two different real roots, right? Again, if discriminant is equal to 0, then we obtain two equal real roots, right? But if discriminant is less than 0, then there will be no real roots, right? In this way, discriminant helps to identify whether a quadratic equation has two distinct real roots, two equal real roots, or no real roots, right? Now, how does discriminant help to identify the nature of roots before solving the equation? Let's take an example. We had a question over here x square plus 5x plus 6 equal to 0. X square plus 5x plus 6 equal to 0. Okay, firstly, in this equation a equal to, okay, we have to assume here 1, so a equal to 1, b equal to plus 5 and c equal to plus 6. And for discriminant we have this formula d equal to b square minus 4ac. Now d equal to, okay, b equal to we have 5, so 5 square minus 4 into a equal to we have 1 into c equal to we have 6. So d equal to square of 5 will be 25 minus 4 1 ja 4, 4 6 ja 24. Now lastly, discriminant will be 25 minus 24, 1. And in this way we came to know discriminant is greater than 0. In these conditions, as we know, if discriminant is greater than 0, then there will be two distinct real roots, right, which we have already obtained by solving these equations over here. Okay, over here x equal to minus 3 and another value of x minus 2. Okay, now let's back to the given exercise. Firstly, question number 1, and here is written, check whether the following are quadratic equations. Okay students, here simply we have to identify whether given equations are quadratic equations or not, right? So firstly, take question number 1, and our question number 1 is x plus 1 whole square equal to 2 into x minus 3. And to identify whether it is quadratic equation or not, firstly we have to solve this equation, right? So in its LHS it has x plus 1 whole square, and as we know it is in the form of the identity a plus b whole square, right? And its expanded form will be a square plus b square plus 2ab. By the same way we can expand this expression too, right? So firstly let's assume this is a and this is b, right? Now it can be expanded like this: x square plus 1 square plus 2 into x into 1 equal to, now let's solve RHS. Here we just multiply to remove the bracket. So 2 into x, 2x plus into minus, minus 2 into 3, 6. Now let's arrange x square plus, and square of 1 will be 1 itself, plus 2 into x 2x and 2x into 1 2x, and this plus 2x comes to LHS and becomes minus 2x, and this minus 6 also comes to LHS and becomes plus 6 equal to 0. Now x square plus, okay, here this plus 2x and minus 2x will be cancelled out, and this plus 1 and plus 6 after adding we obtain plus 7 equal to 0. Now here we can see the highest power of this equation is 2. It means it has degree of 2. So we can write it is a quadratic equation, right? Okay, now question number 2. Okay, firstly let's erase this. Okay, our second question is x square minus 2x equal to minus 2 into 3 minus x. Okay, to identify whether it is quadratic equation or not, firstly we have to solve this equation. So let's start from its RHS, right? X square minus 2x. Okay, here we simply multiply minus into plus, minus 2 into 3 6, and minus into minus plus, and 2 into x 2x. Now let's arrange x square minus 2x and this plus 2x comes to LHS and becomes minus 2x, and this minus 6 also comes to LHS and becomes plus 6 equal to 0. Now x square and this minus 2x and minus 2x after adding we obtain minus 4x and this plus 6 equal to 0. Now here we can see the highest power of this equation is 2. It means it has degree of 2. So we can write it is a quadratic equation.